So today we are going to be doing 6.2 Day 2 notes, which is synthetic division. It is another form of division where we don't have to do all the steps that we do in long division. It's a shorthand version of division, but it only works in some scenarios. So because of that, I'm going to have you start with long division. So you're going to do this problem on your own, and then we're going to compare that to our example for synthetic division. So our goal today will be to divide polynomials using synthetic division. So finish up that long division problem, and then we'll check it. So I started with the setup. Make sure you've done your setup part at least correctly.
I'm not waiting till 5th hour.
All right, so here's, oh, that's frozen. There's the first step. That was my first time going through the algorithm. X times what would give me 2x to the third? I'd have to multiply by 2x squared. So I write 2x squared over here times what I was dividing by, the x minus 4. When I multiply that out, I put that answer in here, but I subtracted it. I distributed the negative, then added up like terms, brought everything else down, and this is what I have so far. So double check that step. Here's the next time I went through the algorithm. X times what would give me the negative 5x squared? I'd have to multiply x by negative 5x. So I wrote negative 5x over here times the x minus 4. Wrote the answer here, put it in parentheses, and I'm going to subtract it. I don't like subtracting, so I'm going to distribute the subtraction. I'm going to add it, add up the like terms. Negative or positive 26 minus 20x is 6x. Bring down that negative 24. Now my last time I go through the algorithm, I'll do it while we're up here. X times what gets you 6x? A positive 6. So I'm going to have 6 times that x minus 4. That answer is 6x minus 24. So I'm going to be subtracting that binomial. No one likes to do subtraction, so we're going to change it to adding the opposite of those terms. 6x and negative 6x cancel to 0. Negative 24 and a positive 24 also cancel, leaving us a remainder of 0. That means the answer to this problem right here, that division problem, is 2x squared minus 5x plus 6. Now I could do the multiplication and double check it, but for right now we're going to skip that because we're actually going to divide it again a second way, and we'll verify it that way instead of multiplying to check. So far, so good? Give me a 1 to 5 on how did this division, long division, go on your own. 5, I did the whole thing on my own. 4, I made a little error, but I fixed it. 3, I have the idea, but I still need some practice. Okay, so synthetic division. This problem is the exact same as the problem number 1 that we did up here. Still a division problem. But we're going to set up using synthetic division. So it says to first write the coefficients of the dividend, which is what we have originally, from the highest degree to the lowest degree. Use placeholders if necessary. So all we're going to do first is write the coefficients. So let's label these actually. This is the dividend. Okay. This is your divisor. And then our answer is what we get. So up here, the top was the dividend, the bottom is the divisor, and then this here was our answer. So we do a dividend divided by the divisor equals an answer. So the first thing that we're going to do is we're going to go through and we're going to write the coefficients. What's a coefficient? Can you tell me what a coefficient is? Did I see a hand over here?
Yeah.
You're thinking what?
If what I'm about to say is right or not.
We'll just take a guess. It's okay if we're wrong.
Isn't it the number in front of the
It's the number in front of the variable. Yeah. So what's the coefficient in the dividend that comes first? What's the first coefficient there? 2. What's the coefficient in the next term? Negative 13. What's the coefficient in this term? What's the coefficient in this last term? Negative 24. So we have 2, negative 13, 26, negative 24. Okay? So what we're going to do is we're going to write those out. However, we need to make sure that we're going from the highest degree to the lowest, and we're not skipping any. So the highest degree here is 3. So this goes 3, 2, 1, 0. Nothing was skipped or missed, so I can just start by writing them all out. So the first one's going to be 2, negative 13, 26, negative 24. That's how I start writing them. Okay? Then I also need this little box over here. So put this like little box off to the left of where you're writing those coefficients. And in this box it says, write the constant r of the divisor, x minus r. So look at your divisor. See how this only is set up if you have x minus r? Okay? If I had 3x minus r, it's not the same thing, and I couldn't use this. So I can only do this when my divisor is an x plus or minus a number. Okay? So x minus r, what is the r in this case? 4. It shows up opposite in the box as it does that in the actual divisor. If it shows up a minus 4 there, it shows up as a positive 4 here. Yes?
Why would it show up as positive 4 and not negative 4?
You'll see why in a minute.
Okay, so then if it was positive 4, it would show up as negative 4?
Yes, if this was x plus 4, this would show up as a negative 4. I'm going to go through and we're going to compare because we're doing the same problem here as what we did up here, and you'll see why it has to be a negative. Okay, so we'll put this line underneath here. And it says bring down the first coefficient. So this 2, you just bring it down. And then we have this algorithm. Again, another algorithm. It's kind of the key word this week. It says take the number brought down, multiply by the box. 2 times 4 is 8. It says, and write under the next coefficient. 2 times 4 is 8, so we write this answer right here. Okay, it says to add the row. What's negative 13 plus 8? Negative 5. Repeat steps 2 and 3 until done. Take the number brought down, multiply by the box. Negative 5 times the box is 4. So negative 5 times 4 is negative 20. Add the row. 26 and negative 20 makes 6. All right, repeat steps 2 and 3 because we're not yet done. 6 times the box. 6 times 4 is 24. We're going to write that answer here. Add the row. Negative 24 and 24 make 0. And we're almost done. Okay? We did all the hard part. The next part's not too bad. You're going to think about this last one as separate from everything else because that there is your remainder. If you have a remainder, that's what's there. Then this is the one with the degree 0. This is the degree 1, and this is a degree 2. So the way that you write your answer, if it was a degree 2, you would have had 2x squared. The degree 1 would be minus 5x. The degree 0 is plus 6. And you don't have to worry about the added remainder there. This would be your answer. Look at your answer that we got down here compared to the answer we got up here. It is the same. 2x squared minus 5x plus 6. 2x squared minus 5x plus 6. It works. Okay, now Tyler asked a really good question about why does that number have to show up as opposite? I'm going to show you right now. You are doing the algorithm of long division without having to write in all of the coefficients every single time. Okay, so let me zoom out so I can kind of show you what's happening here. If you're not following this, that's okay. I'm never going to ask you to explain it, but Tyler did ask the question, so I want to make sure that he understands why it shows up opposite. Okay, so we brought down the 2. We had the 2 for the 2x to the third. We said, okay, we figured out what we'd have to multiply by. That came out right here. And when we did that, we said 2 times, here we multiplied by -4 to get this number as +8. Or wait, no, it was a -8, sorry. But since we were subtracting it, it became a +8 right here. So by multiplying the 2 times the -4, that's exactly what we did right here, 2 times 4. But then instead of subtracting it, we wanted to add it. So we made this the opposite. So 2 times 4 was an 8, and we added it. Just like we added -13 and 8 up here, we did the same thing and got -5. See how that repeats down here, but you just have a lot less you're writing because you don't have to write in all those variables. Then we said that we had to take that -5, because we have the -5 again over here, times the -4, but we made it opposite so we could add it. So -5 times -4, we got the +20, we made it negative. We have the negative. Then we added the 26 and the 20, 26 and the 20, and got our 6. That's where that 6 came from, and we said 6 times -4 to get our -24, but we made it opposite because we were subtracting. So 6 times -4, make it opposite. 6 times 4 becomes 24. We added -24 and 4, or -24 and +24 to get 0. Same thing we did in that last step. Okay? All of it's the same, except for there's a lot less writing when it comes to synthetic division. So if you can, I would recommend using synthetic division when you can. However, on a question like on your homework where we were dividing by 3x plus 1, this is not set up for synthetic division. So you wouldn't be able to use synthetic division here. You'd have to rely on long division. Does that make sense? Which is why we have to learn long division first and understand it to make sure that we don't just completely ignore it. Yes?
Can we convert that somewhere?
We'll talk about that. Okay. But first, what we're going to do is this one here, which is another division problem, right? Because if you have x plus 3 raised to the -1st power, that's the same thing as 1 over x plus 3. So if it's on the denominator, you're just dividing. Turns it into looking like this top one, okay? So all this is division. So if you want to rewrite it, you can, or you don't have to. Anyways, I'm going to set up my synthetic division. What's going to be the number in the box this time? Remember, this is your dividend. This is your divisor. And we're looking for the answer. What goes in the box? -3, because it shows up opposite that it does here. So we're going to put a -3 in the box. We need to make sure that when we write our coefficients that we don't skip any degrees. So double check. What's the degree of the first term? What's the degree of this first term? 3. What's the degree here? 2, 1, 0. 3, 2, 1, 0. I didn't skip anything. I counted down. So I'm going to write my coefficients are 2, 3, -4, and 15. Give me a 1 through 5. I think I can set that up on my own. Like, I can get that part. Okay, cool. What do I do first? Drop down that 2. Then what? Multiply by the box. What is 2 times the box? -6. Write that answer in that next open space. What do I do with the 3 and the -6? Add them up. what is 3 plus negative 6? Negative 3. Negative 3 times the box is positive 9. Put it there. Add up the row. 9 and negative 4 make 5. Now what? Multiply 5 by the box, negative 3. You get negative 15. Add them up. 0. I like to put a line there so I remember that this here is my remainder. I want you to try to take that answer and write it as your actual answer, because your answer is not 2, negative 3, 5. Your answer is a polynomial. What polynomial is that answer? How are we going to write it? When you think you have it, raise your hand. Preston, go ahead. What do we got?
2x squared minus 3x plus 5.
Let's double check. We had a degree 0, 1, and 2. They were all in order, and we didn't have a remainder. That looks good. So this would be your answer. Yes?
Maybe this is a dumb question, but do we just ignore the negative 1 on the outside of the parentheses?
The negative 1. This?
Yeah.
That tells you that that's being divided because it moves it to the denominator. The negative 1 up here. If that wasn't there, what kind of problem would actually that be? What kind of problem, what operation are you doing here if that negative 1 wasn't there? Distributing, which is multiplication. Okay? The negative 1 tells you that this set of parentheses moves to the denominator. So you have this as the numerator, this is the denominator, which then looks like number 1. So you have a polynomial in the numerator and a binomial in the denominator, which makes us understand that it is division. Does that make sense? Yeah. Okay. All right. So are we okay with how we came up with that answer? Yes, go ahead.
So, I'm good with, like, getting the actual numbers.
Yep.
But where do you get the x squared?
Because I know, okay, so you're good with coming up with these numbers, but you don't know where these variables are coming from.
Yeah.
Because we know that this has to be the remainder, okay? This has to have a degree of 0, meaning it has no variables. This then has a degree of 1, meaning it has to be x to the first. Keep counting up. This is your remainder, 0, 1, 2. This has to have a degree of 2, so it has to be x squared.
Oh, so then if there was, like, 5 numbers, it'd be...
The next one would be a degree 3. Yep, if this kept going, if it was longer, the next one would be a degree 3. So it would be x cubed. The next one would be a degree 4, x to the 4th. Yep, they just go in order. Okay, good question. What else? I saw another hand up.
Oh, I had the same question, Tyler.
So we're good?
Yep.
Okay, same question. All right, we have to check it. We have to check it the same way that we were doing before. So remember, you check division using multiplication. So what are we going to multiply here? Yep, x plus 3, that's what we were dividing by, times 2x squared minus 3x plus 5. So I distribute my x through. If you want to use the box method, that's totally fine too. But I'm going to distribute that x through to all three terms. I have 2x cubed minus 3x squared plus 5x. Then I'm going to distribute the 3 to all three terms. And I get plus 6x squared minus 9x plus 15. And then I'm going to go back and I'm going to combine like terms. And some people really struggled on this on the quiz, so I'm going to zoom in and we're really going to focus on how do I combine like terms. X cubed, there are no other x cubed. That means there are no other like terms. So 2x cubed is the only lonely term. So 2x to the third. So now the next term is going to be an x squared term. So I'm looking for all my x squared terms. So I have negative 3x squared and a 6x squared. Now, when you add cookies to cookies, you still have cookies. You just have more of them. So when I have x squared and x squared, I'm still going to have an x squared term. It all depends on how many. Some people were changing x squared and an x squared term, and they were getting something I don't even know what. So negative 3x squared and a positive 6x squared. If I have negative 3 cookies and 6 cookies, I have 3 cookies left. 3x squared. Okay, so I took care of that, Then I have my x terms, so 5x and negative 9x. Okay, now I have oranges and more oranges. I'm still going to have oranges. It just depends on how many of those oranges I have. So if I have 5 oranges and I take away 9 oranges, I'm short 4 oranges. Minus 4x. Okay, that took care of those two. And then my last one doesn't have anything else like it, so plus 15. How did that help me check? What do I have to look at? Make sure that this matches with the original. Okay, so make sure 2x to the third plus 3x squared minus 4x plus 15 looks good, and I'm good to go. So far, so good? All right, let's flip it over. And I want you to try number 3 on your own. But double check. Your divisor, your dividend, starts with a degree of 4. Count down. Degree 4, 3, what's missing? The 2. So what's the coefficient on the degree 2? 0. So you'll want a placeholder. So when we have the box, and I'll help you with the setup, but then I'm going to have you guys do the algorithm on your own. So I'm going to start with a 6 and then a negative 8 for 4, degree 3, degree 2 was missing, so what do I put as my coefficient? 0. 4, 3, 2, 1 is a 12, and the 0 was negative 14. So that's going to be my setup this time. What goes in the box? What goes in the box? Positive 2, because it shows up opposite. B minus 2 will show up as a positive 2. Go ahead and do the algorithm. Okay, so doing the algorithm part, again, make sure you're double checking all your multiplication and addition with a calculator, because a simple thing like 6 times 2 and accidentally writing the wrong number here will make everything else wrong. And if that's the case, you lost a lot of points on a simple problem, okay? Even on the work part of your problem. So I bring down the 6, 6 times 2, write that answer there. 12 plus negative 8, I write that answer there. Times 2, write that answer here. So it's easy to just use a previous answer. Plus 0, 8 times 2, 16, wrote it down here. Plus the 12, got 28, 28 times 2, got the 56, plus negative 14, got the 42, and I was done, and I double checked my multiplication and adding. Does that make sense? So it's very easy and quick to use your calculator just to double check that, because you don't want to mess up on the adding or multiplying, because that's the simple stuff. Okay? So then how do I have this? How do I write my answer from that? This is your remainder. What does 6 have a degree of? That's your remainder. This has a degree of 0. You got to start with 0. 0, 1, 2, 3. It's always going to drop a degree from where it started, and it was at b to the 4th, so this would have to be 6b to the 3rd. What comes next? How do I write the next one? Plus 4b squared plus 8b plus 28 plus, how do I write that remainder in? 42 over, what did we divide by? The b minus 2. Very good. So that would be your answer. So far, so good? All right, then in order to check this, when I go to check this, I'm going to take that b minus 2, and I'm going to multiply by what I got, 6b to the third plus 4b squared plus 8b plus 28 with a remainder of 42. So I'm going to add the 42 on the outside. Now, for those of you that like to do the box method, I'll show you the box method again, because again, you're using multiplication. So here's my box, will be my multiplication, plus the extra 42. Okay? I have a 2 by 4. I'm going to have the b minus 2, 6b cubed, 4b squared, 8b, and 28. Six b times b is 6b to the fourth. 4b squared times b is 4b to the third. 8bb is 8b squared, 28b. Okay, next row. Negative 12b to the third minus 8b squared minus 16b, negative 56. Now it's nice because my like terms are kind of almost lined up. They're just lined up on a diagonal. So my answer is 6b to the fourth, or actually not my answer, but what my original thing is supposed to be, is 6b to the fourth, negative 12b to the third, and 4b to the third is how many b to the thirds? Minus 8b to the third. Okay. Negative 8b squared and a positive 8b squared. How many b squareds do I have? 0b squared. Okay. A negative 16b and a 28b. How many b's do I have? 12b. And then I have my negative 56 and the positive 42, which should be negative 14. Is this what I started with? This is what I had on top. The only thing I did that looks a little bit different is that I wrote in 0b squared, and up here it's not written in. But that's okay. 0b squared, if it's not written in, is the same thing as 0b squared. Okay. Yes, go ahead.
So you have to write that, or
Well, this, it doesn't matter if you, yeah, you could have left this out completely and had just that if you wanted to. I just wrote it in so I knew I didn't skip a term. Okay. But 0b squared is the same thing as not writing it like it was up here. So we can say yes, then this is our final answer because I checked it and I know that I got it right. Now, the next one. This is not set up for synthetic division. Why? It has a coefficient before the x on the bottom. That 2 there doesn't allow it to be set up for synthetic division. However, I can rewrite this as 2 times x minus 4. I can factor out a 2 to both of those terms. Is that okay? I can factor out a 2 then on top, and I'd get 2x to the third minus 3x squared minus 18x minus 8. And what's 2 over 2? What's 2 over 2? 1, so that becomes 1. And now can you use synthetic division? Yes. And I don't remember who asked, but someone asked if there was a way we can convert it so you could do synthetic division. That's how this would happen. However, be careful, because if these were not all even numbers on top, you would then be dealing with fractions. And I wouldn't recommend that because things then get messy. Okay, so now this is set up for synthetic division. And on top, we have our box. We have 3, 2, 1, 0. So that's all set up. What goes in the box? What goes in the box? 4. Okay. Yes?
That's -6, not
-6. Are you talking about up here? We have to divide all these by 2 because we factored out the 2. So that way we factored out a 2 on top and a 2 on the bottom, because that was the only way that we'd have x by itself on the bottom. Are we okay with that? So we're okay with my setup here? Okay, so then doing the algorithm, bring down the 2, multiply, add, multiply, add, multiply, add. Okay, so then what's our final answer here? 2x squared plus 5x plus 2. And just to save time, I'm not going to show you again how to check, but that's what our answer would be. Yes?
So when you do check, do you check it with the x minus 4, or do you check it with...
Yes, you would take this times the x minus 4, and then it would have to equal the top.
Of the new...
Yep, or if you did it this times the 2x minus 8, it would have to equal this top. You can do it either way.
As long as it's one or the other. Not...
Yes. Yep, so focus on one or the other, not a mix of both.
Okay.
Does that make sense? All right, so this last one, I'm going to show you why this gets super messy. Okay? If you factor out the 3 on the bottom, we have x plus 1/3. See it? Okay, if we factor out a 3 on the top, we're now going to have x to the 4th minus 5/3, x to the 3rd, plus 1/3, x squared, plus 7/3x, plus 0. I'm going to write the plus 0 in because 4, 3, 2, 1, 0. I didn't want to miss a term there. See how messy that gets because there are all those fractions there. I would suggest just doing long division there because I promise I will not give you terrible, terrible numbers to work with if you choose the proper method. Okay? I will still do this problem for you using synthetic division to show you everything's okay in the long run. However, it's a lot of fractions and messy work along the way. In this box, because your 3's cancel, you'll have a -1/3. Across on our coefficients, we have a 1, a -5/3, a +1/3, a 7/3, and then a 0. You have to remember your 0 there. When you bring this down, this is a 1. When you multiply, it's still going to be -1/3. -5/3 and -1/3, now we're adding fractions together, which is -6/3, which is actually -2. Now not only are we adding fractions, but then we're going to have to simplify fractions. -2 times -1/3 is going to be a +2/3. 2/3 and 1/3 is 3/3, which is actually 1. 1 times -1/3 is -1/3. 7/3 minus 1/3 is going to be 6/3, which is 2. 2 times -1/3 is going to be -2/3, which is -2/3 will be your remainder. That looks pretty messy, but I'll write what out the answer would be. Since this was an x to the 4th, this dropped to a 3rd, so x to the 3rd minus 2x squared plus x plus 2 minus 2/3 is how we're going to write that fraction. But we have to remember that in the denominator, you have your original, what you were dividing by, which was this problem that we just did, which is x plus 1/3, which then you have to simplify your remainder so that this reads x to the third minus 2x squared plus x plus 2 minus 2 over 3x plus 1, which you'll notice is what we originally started with. It would have been just easier and a lot less fractions using long division there.